Now for the metamorphic rock, how metamorphic rock are formed? Metamorphic rock are formed from the older rocks when they are subjected to increased temperature, pressure and shearing stresses at considerable depth in the earth's crust. So the older rock may be either sedimentary igneous or uncompacted metamorphic rock, or low grade metamorphic rock. What is the grade? I have already discussed. So during the metamorphism, recrystallization takes place essentially in the solid state, and new minerals, new textures are produced. So in your last class, that combined class, I've initially told about the metamorphic rock like the slate, and at this point I hope you got some idea about the metamorphic rock, because you did attend a class yesterday or the day before yesterday. Okay. So what are the agents of metamorphism? The main agents of metamorphic rock, how metamorphism happen, and what ignites or what basically drives the metamorphism. That means the transformation of rock, any existing rock, into different type, like limestone. You know, limestone is a sedimentary rock, okay, and in this limestone, it can be, when it goes under the metamorphic goes under metamorphism, after metamorphism, what it will convert it into marble. So the main constituent of limestone is calcium carbonate. Marble is also calcium carbonate, but the characteristics, the properties is totally changed. One simple, or what we can understand in layman's term, that if I see two type rock, that in one hand I have limestone, one hand I have marble, then you can easily say that, okay, I can polish the marble, but I cannot polish the limestone. That will not give you the shiny effect. Okay, so marble, after polishing the marble, you get a shiny kind of structure. That's why marble is used in flooring. Limestone is not. Okay, so limestones are made of, or limestone blocks are made of or used for that pyramid building thing. So it was the main brick-like structure of any pyramid in Egypt. Okay, so totally its entire grain arrangement or entire structures changes, and these changes are happened only because two element. One is heat, okay, as second agent, most important, that is the temperature. Sorry, that is pressure. Heat means temperature and pressure. Okay, so these are the two agents of metamorphism. Other than this will be and another thing could be happening, that is the, when you will be talking about the chemical induced metamorphism, then another agent may be there, that is the chemical agent. Okay, so heat within the earth, the temperature increases, you know that. Let's talk about heat. So if we move towards the earth center, the temperature will be increasing. Okay, that part will be discussed in your seismology chapter also, that how temperature varies with the earth's depth, and this is depth from the surface, this is the surface. Okay, so within the earth, the temperature generally increases with the depth, and as a result, appreciably high temperature exists at great depth. 1 point. So at a depth, you will be find at great depth you will have high temperature. And another point is that at certain, so if your existing rock is on the way, or on the existing rocks located on the way of the magma intrusion, so magma intrusion happening and the surrounding existing rock, so from magma chamber the magma intrusion is happening. Dike seals I have already discussed. So this is the, let's say this is the magma intrusion and this is the existing rock. So surrounding things will be changing due to this high temperature. It's called, there is a metamorphism type that's called the thermal metamorphism or contact metamorphism. So high temperature magma comes in contact with the existing rocks and it changes the characteristics of that existing rock. That's called your contact metamorphism, and here heat is responsible. Okay, so that's the condition for the subsurface condition. Now how heat plays a role in the outer earth condition. So in the outer earth it causes elevated temperature in the intrusion of the hot igneous body, or when the volcanic when the magma comes out as lava and it interacts with the surrounding rock in the atmosphere. So what will happen? This high temperature lava will generally melt the existing rock, or it will be changing that rock into a different kind of rock. So it will be initiating the metamorphism. So heat plays an important role in metamorphism. Another agent of metamorphism is your pressure. So pressure could be two types. One is uniform pressure, another one is the directed pressure. So the static pressure on rock is caused by, suppose there is a rock which is at certain depth from the surface. So just like the water, so if you are keeping anything underneath the water or water body, so what will happen? You know the formula rho GH. Okay, so the H is the water column. So suppose you are keeping a block here and this much of water is here, so this is H. So what will be the pressure exerted on this? Rho GH. Okay, similarly it will feel a pressure. I'm not giving any extra pressure. It will feel a pressure, and over the years it will be feeling the same pressure. It's called the uniform pressure. And under this pressure, or under the, due to the overlying, the rock staying above that block, or rock staying, or the materials situating in between the surface and the rock's body is giving the pressure, and this type of pressure is called the uniform pressure. Another type of pressure is there, that's called the directed pressure. In case of directed pressure, or stress operate during the folding movements that accompany the mountain buildings. So directed pressures are generally, you can consider a earthquake event, and this earthquake event is contributing or it's basically changing the landscape. How? It may create a fold, it definitely creates some fault. So what will happen? Sometimes you will see in your structural geology class, along the fault plane a block will be slipping downward, okay, along this fault plane. This is called the normal fault. So that will be discussed. So this type of, due to this type of things, a new pressure will be created or new pressure will be directed. That's called the directed pressure. So pressure is also plays an important role in metamorphism. So under if pressure is only responsible, then we will be seeing cataclastic metamorphism. Last class I have discussed. So cataclastic metamorphism, only pressure is acting, temperature, I'm not considering the temperature effect. In the contact metamorphism, we are considering the temperature effect, but I am not considering the pressure effect. That's the basic difference between cataclastic and contact metamorphism. In your in the third portion, so what will happen here? The chemically active fluid and gases. So chemically active fluid and gases can also changes the rock type, and it can convert or it can transform a rock, a sedimentary or igneous rock, or any or low grade metamorphic rock in another type of rock. So chemically active fluids and gases, when passed through the pores and rocks, they bring about the changes in their original compositions. It's called the chemically induced metamorphism. Okay. So what are the process of metamorphism, if you ask? These are the agent of metamorphism, means which parameters or which factors are responsible for metamorphism event. Okay. Now we'll be discussing what are the processes of metamorphism. What can happen during the metamorphism? What actually happens in a metamorphism? So first happen is the granulation. So this is happened due to the pressure, and pressure generally shattered the rock. It's making a small fragments of the rock, and the friction is so great that the rocks are partially melted. Due to the pressure, the rocks are shattering, and due to that event, there is a friction involved, and friction generally creates so much of it that it can partially melt the rocks. And this process is called, this process of crushing of rocks and becoming a or forming a new one, it's called the granulation. Another type of structure or process involved here is called plastic deformation. So when the rock minerals is subjected to stress, stress is proportional to the strain. You are familiar with plastic deformation, I know. Like the Hooke's law, from there you can define plastic material, elastic material, non-elastic material. Okay. So plastic deformation takes place when a rock or minerals or other substance is stressed beyond its elastic limit. Then generally plastic deformation happens. Recrystallization and metasomatism. The most important one, the most important process here is the metasomatism. So metasomatism is the process in which the original composition of rocks are changes, primarily by addition or removal of the material. So in your igneous geology class, I was discussing that when a magma moves through a rock body in a so this is the rock body, this is the magma intrusion is happening. So what will happen in this contact? It could add or it could differentiate, or it could so two things can happen. The surrounding minerals could be added to the magma flow, or the magma may contain several minerals, and that mineral compound may be what's the actual term, differentiated actually. Okay. So one part is called magma assimilation, one is called differentiation. So the assimilation parts mean is including the surrounding material. Differentiation part means the own component of the magma is splitting into two or other three halves. Okay. So if it's taking the surrounding minerals, then assimilation. If it's splitting into other minerals, then it's called differentiation. So these two things can happen. Similarly for metasomatism, this is the process where the original compositions of rocks are changed. It's called metasomatism. Okay. So either you will be adding, or you will be subtracting the, or you will be removing the material. By this way you are changing any existing rock into a metamorphic rock, and this process is called metasomatism. Okay. Now metamorphism zone, the zone of metamorphism occurs near the earth surface. If it's occurring in near to the earth surface, it's called the epizone. If it's occurring in the middle portion, it's called the mesozone. If it's occurring at a depth, then it's called the catazone. Yes.
Can you please repeat granulation?
For which part you didn't understand?
Granulation, sir. In granulation, sir, partial melting leads to granular, sir. How, sir?
How?
Partial melting.
the pressure is shattering the rock, it's making smaller fragments, along with it's also melting the material. So what we need for metamorphism? Pressure and temperature, a suitable pressure and temperature. And in this process, when the pressure is shattering the rocks, in this process the crushing rock takes place without loss of coherence. Means this rock basically changing into the another type of rock. After crushing, it's becoming a metamorphic rock due to the pressure which is to crush the rock and the temperature created due to the friction. And this process is called granulation. So what you didn't, which part you didn't understand?
Sir, I thought sir granulation means converting to granules, sir.
No. The process is called why granulation? क्योंकि ये ना छोटा छोटा फ्रेगमेंट्स में डिवाइड हो जा रहा है. लार्ज रॉक बॉडी बिकमिंग ए स्मॉल फ्रेगमेंट्स ड्यू टू द सैटरिंग, ड्यू टू द प्रेशर. ओके, इसलिए जो ग्रेनुलर डिराइव्ड होता है, देन इज फॉर्मिंग ए डिफरेंट टाइप ऑफ रॉक एंड as is first is becoming a small grains, that's why it's called granulation. It's a simple thing, nothing not a
सर ग्रेनुलस में क्यों बदल जाता है सर? उसको सर मतलब मेल्ट हो रहा है तो लिक्विड में होना चाहिए, स्टेट अपना चेंज करना चाहिए सर, स्टेट अपना ग्रेनुलस में
उसके बाद तो फ्रीज होगा ना.
कैसे बदलेगा?
You didn't understand the
तो सर एक दूसरे स्टेट ले लेना चाहिए सर, ग्रेनुलस को हो जा रहा है, टुकड़े कैसे हो जा रहा है?
metamorphism is metamorphic grades basically refers to the range of metamorphic change a rock undergoes. ग्रेड मीन्स क्या होता है, कितने अच्छे से मेटामॉर्फिज्म हुआ है, हाउ गुड योर मेटामॉर्फिज्म प्रोसेस occurred, हाउ गुड ए मेटामॉर्फिक रॉक इज फॉर्म्ड. If it's not forming good enough, the compaction of the rock or the rocks are not that much of strong. So metamorphic rocks are generally strong. I am saying that's not the geological word. That means it will be very compacted. When I say metamorphic rock, then you will visualize that it's a hard compacted rock. Generally it should be, but most of the cases you will not see that hard compacted rock, because you are not giving enough time to become a hard compacted rock. You are not giving enough time, temperature and pressure to become its full or to attain its full potential. Let's say जैसा होना चाहिए तो वो हो नहीं रहा है. Because of that you will have another type. Because of that you will have the low grade metamorphic rock like slate. And slate is the metamorphic rock we used to write in our childhood with chalk and all. So that was actually the slate. We called it a slate, but it was actually the slate rock. It's a metamorphic rock. It's a kind of flaky, or it's a kind of, it has several cleavages and is consisted of layer after layer like onions. You will be seeing thin layers. If you break a slate, you will be seeing thin layers, and you can easily detach the layers. But in a hard compacted or high grade metamorphic rock, you cannot detach or you cannot easily break the metamorphic rock. So if you got a good metamorphic rock and you are planning to do it or you are planning to construct a dam on that rock, then you should go for it, because it's not permeable, it's very compacted, and it's a, in our layman's term or in simple term, I'll be saying it's a hard rock. Okay, if you got slate, then you shouldn't be going for the dam or other construction. So this is how the grade of metamorphism changes. And one more thing, that how pressure and temperature and what are the contribution of pressure and temperature. So geologists uses generally the index minerals that form the certain temperature and pressure to identify the metamorphic grade. So depending on the pressure and temperature, see one example, kyanite, andesite and sillimanite. It has the same chemical formula, but different pressure zone it will have a different formation, the different arrangement of the grains. different texture you will be seeing. Okay, so in low temperature and low pressure at this point, consider at this point, follow my like better. So here what I have, kyanite at low temperature, low pressure. Now I am keeping the pressure fixed and I am increasing the temperature. What will happen? This kyanite will be transformed into the andalusite, and this andalusite, the chemical formula is same, Al2SiO5. So kyanite will be transforming into the andalusite, and andalusite will be transformed into sillimanite if I increase the temperature. That's the basic. Okay, so here the is showing the phase diagram of 3 index mineral. Okay, same chemical formula these minerals have, but it has different crystal structures. It's called the polymorphism, and is generally created by different pressure and temperature condition. So depending on your pressure and temperature, the rock type, rock arrangement, the sequence of low to high grade rock changes. So kyanite could be a low grade range. If you are giving enough temperature and pressure, you will be getting a sillimanite, which will be a high grade metamorphic rock. Same thing you are converting. Okay. Metamorphic rocks are formed like that under pressure and temperature, and if it gets much time, the metamorphic grading will be more. So metamorphic rocks are formed from the older rocks when they are subjected to increased temperature, pressure, shearing stress at considerable depth in the earth's crust. Okay, now this metamorphic rock has several textures. We already know about the igneous rock textures. We read holocrystalline, holohaline, euhedral, polyhedral, euhedral, genomorphic. So the textures for the metamorphic rock, or in a metamorphic rock, first one is the crystalloblastic texture. It's called the crystalloblastic texture. So in case of crystalloblastic texture, the holocrystalline texture of metamorphic rocks you can see. So what do you mean by holocrystalline texture? So it totally or entirely made up of crystals. Then the structure was used to call, in case of igneous rock, we used to call that a holocrystalline texture. Similarly, if you see this kind of holocrystalline texture, then in case of metamorphic rock, I'll be saying it a crystalloblastic texture. The texture, the arrangement, geometrical shapes, or this type of things are almost similar, but for igneous rock I am calling it a holocrystalline. For metamorphic rock I am calling it a crystalloblastic texture. Now this is developed due to the recrystallization of mineral grains and the solid medium. It can be divided into two types, idioblast and genoblast. If the mineral grains is euhedral, then it's called the idioblast. So what do you mean by euhedral? If you are seeing through the microscope and the structure is have a perfect edge, then this type of structure, in case of, remember the igneous rock, okay, then this type of structure is called, it's called euhedral shape. Now what will be calling that if there is no perfect outline, if you are seeing this crystal structure through microscope, then this will be called as, class, hello class, Satish, from the igneous rock, just tell me what it will be called. Sabyasachi, anyone?
Yes, sir.
What it will be called if it's a euhedral structure? If this one is a euhedral shape, what it will be called? It's a genomorphic structure for the igneous rock. Okay, now if these things are if you can see this kind of structure for igneous rock, then you will be saying it's a euhedral texture. If this kind of structure textures you can see in a igneous rock, then it's called geomorphic textures. For metamorphic rock, this texture will be called as a idioblast. If you find this kind of textures just like the euhedral textures, then it will be called as a idioblast. Write this down, and I told you to take notes, so whatever I am drawing, draw it properly or roughly on your copy and just point it out so that you can understand later. I know that most of you are not writing, most of you are not taking notes. You thought you will be reading and you will be this will be done, but see, believe me, if you are taking notes, that will be much helpful than reading. Okay, so that's the idioblastic. For the metamorphic I'll be calling. If it's a geomorphic structure, you will find where not perfect outline you are seeing in a crystal, that geomorphic texture or this kind of textures will be named in metamorphic rock, or in case of metamorphic rock I'll be saying it as a genoblast. Okay, so for igneous I'm calling euhedral. That euhedral, if I'm seeing in metamorphic, I'll be saying it's a idioblast. If a geomorphic structure or anhedral textures are in a igneous rock, then that texture, if I'm seeing on a metamorphic rock, that I'll be saying it's a genoblast. You'll be adding the blast here. Okay, now so for igneous rock, geomorphic, euhedral, porphyritic. In metamorphic rock I'll be using the blast as a suffix. Okay, now another type of texture that is most common, that is the porphyroblast or porphyroblastic texture. So porphyroblastic texture, when the idioblast occurs large crystal embedded in a fine grained ground mass. So what is a porphyritic texture in igneous rock? You know about this. So porphyritic texture means if there is a suppose this is the large crystal, you can see this is the last crystal. It's called, when I am talking about the igneous rock, porphyritic structure. When I am talking about the porphyritic texture for the igneous rocks, this is called, this larger crystal is called, anyone from the class? Yeah, what? Tell me. It's called phenocryst. It is your phenocryst crystal, and the finer grain background material is called ground mass. I think I have repeated several times. Okay, now in case of metamorphic, if you are seeing similar kind of texture, then I will be saying it is a porphyroblastic texture. So I'll be adding a blastic term, so it will be called as a porphyroblastic texture. Similarly, there is another kind of textures generally present in a metamorphic rock, that is your granoblastic texture. In a metamorphic rock, if the major constituents are granular or equidimensional, the texture is called granoblastic. Palimpsest texture, the remnant texture of the parent rock found preserved in the metamorphic rock, is called the palimpsest texture. Now this is the most important topic. Up to this I have discussed in the previous class of section A. Now this will be new to section A and section B for both. And metamorphic structures, it can be classified into 6 type, I think, sorry, 7 type. First one is the cataclastic structure. This is produced under stress and absence of high temperature. So under pressure, generally the cataclastic structures are formed, and it is formed by, there is a type of metamorphism, it calls the cataclastic metamorphism. That's happened only with high pressure, only with high pressure. So there is a term called, there is a metamorphic term that is called cataclastic metamorphism, and that's happened only by high pressure, no temperature is present. Remember this, temperature is not present or not available, only high pressure. If any metamorphic event happen, then it should be called as a cataclastic metamorphism. And cataclastic structure is called the metamorphic rock formed by cataclastic or cataclastic metamorphism is called cataclastic structure, or cataclastic structure is found on the rock where you have a fragments of crushed breccia. So breccias are generally angular shaped structure, I have already discussed. Yes, cataclastic metamorphism is only happening. So generally, in general case, I told you that metamorphism happened only under high pressure and temperature, or only under suitable pressure and temperature. But in case of cataclastic metamorphism, only high pressure is acting, no temperature or nothing is as such, or high temperature is available at that point. So is the metamorphism happened only because of high pressure. And where you can find this type of metamorphism? It is found in generally crushed breccia, and is found under certain depth in the subsurface. So if this is the earth surface at certain depth, so pressure increasing with the layer, or pressure increasing with the material in between this line and the earth surface, or this point and the earth surface. So this is the depth, and metamorphism, cataclastic or cataclastic metamorphism happened there due to high pressure, and temperature is, or the variation or the contribution of temperature is almost zero or almost nil. So these type of structures are found in rocks where the breccias and myelonites. So these rocks are formed only mainly the influence of higher pressure, as like the cataclastic metamorphism, and harder constituents of rocks are broken into pieces while the softer ones are crushed into powders. Softer ones are crushed into powder. So this type of structures are called cataclastic structure. Another type of structure is also present or also observable in metamorphic rock, that is Meculos structure. So when argillaceous rocks like clay-like particles, the rock made up of clay-like particles, are going through the contact metamorphism. So at the end of the PPT, I will share a PPT today of this class PPT. At the end of the PPT, you will have a type of the metamorphic or type of the metamorphism. Okay. So if you want, you can understand how this contact metamorphism happen. So contact metamorphism is generally happen due to the temperature, where the contribution of pressure is nil. Okay, almost nil. So if magma is traveling, suppose the magma is traveling like this, and along the way it's coming contact with the existing rock. This is the existing rocks surrounding. When it's coming contact in the with the existing rock, so what will happen at this point, at this contact, the minerals differentiation or assimilation might happen. That already discussed in your igneous class. That generally when magma is flowing, it takes the magma, basically includes or differentiate its component. Okay, so it might take some components from the surrounding material, and due to the high temperature and pressure, and because magma is very hot, due to the high temperature and the pressure is zero here, and this extreme hot magma basically helps to change the characteristics of the rock, and it converts the existing rock into a metamorphic rock. Okay, and that type of structure generally, and then generally macular structures are present. So macular structure, for macular structure, two things might have required. First one, the rock will be argillaceous, that means finer particles or clay particle rock, the existing rock before metamorphism, and along with it should be presence of high temperatures. So those two things will give you a macular structure, and the macular structures, the spots of the spotted rock due to the development of bigger crystal, like case of some minerals andesite within the fine grained garments, and this structure is called the macular structure. Another most important one, you might want to put a star there, that is your slatty structure. I'm talking about the structure, not texture. Slatty structures are kind of it's also called the slatty cleavage. These structures commonly developed in shells that undergo slight metamorphism. Slate in our childhood, actually we used to write on the slate and chalk. Okay, so that slate is made of, or actually made up of the slate rock, or the slate rock is a metamorphic rock. Okay, so slatty structures are generally low grade metamorphic structure. In layman's term, मेटामॉर्फिज्म हैपन क्या होता है ना, खाना अच्छे से पका है, खाना नहीं अच्छे से पका है. जब खाना अच्छे से नहीं पका है तब लो ग्रेड मेटामॉर्फिज्म मीन्स दैट आई एम मीनिंग टू से you are not giving much time to metamorphosing the existing rock. So low grade metamorphism happen, and slatty structure is the low grade metamorphism. So there are several weak planes in between, and these are made up of stacking of layers. So layer after layer, just like onion you can say, and that type of structures is called flaky structures. Okay, and if in generally in slate kind of rock you will find these slatty structures. Rocks showing slatty structure are very fine grained, composed of microscopic flakes or mica. So the slatty structure is caused due to the parallel orientation of the flaky minerals, mainly micas and chloride. That's called the slatty structure. So this is the slatty structure. This is how a slatty structure looks like. Okay?
Sir,
Yes.
this structure is one of the part of 7 different
Yes.
metamorphisms.
So I am talking about the structures. First one is the cataclastic structure. Second is the macular structure. You have to understand. So when you will be reading the structures, you have to understand how they look like. First of all. Second, you have to see, like the macular structure, you will be seeing some spot in the rocks. You will be seeing some spots, some white spot within a black background rock, or in a darker shade rock you will find some spot. That's the macular structure. Then cataclastic structure, you will be seeing some angular breccias and myelonites. For why it's not working? For slatty structure, you will be seeing the slatty cleavage like this. These are called the slatty cleavage. So layer after layer, and those are connected with the weak plane. Okay. So in between two layers, you have a weak plane. So that's called the slatty structure. Now the fourth type is the Systole structure. Very important. You might wanna just put a star there. Write Systole structure. Put a star. Schistose, Nissos, both these structures are very important. This type of structure and this type of rock you might have seen in your neighborhood, that this is most obvious structural features of most metamorphic rock. This is very common, where the alignment of minerals are in parallel layers, like this. The parallel arrangement of platy or flaky minerals brought about the recrystallization during the regional metamorphism. So there is another type of metamorphism exists, that is called the regional metamorphism. Okay. So regional metamorphism, when the directed pressure and heat act together in the presence of migrating hydrothermal fluid. So suppose magma is moving, and in case of contact metamorphism, only temperature is working. First you understand this part. In case of contact metamorphism, I am talking about the metamorphism type. Only temperature is working. Contribution of pressure is almost zero. Okay. In case of regional metamorphism, the magma is moving and changing the surrounding rocks, and here the temperature and pressure both are working. Temperature is contributing, pressure is also contributing, then it's called a regional metamorphism. The process is called regional metamorphism. Got it? So far I have covered contact metamorphism, regional metamorphism and cataclastic metamorphism. Okay. So cataclastic metamorphism में क्या होता था? Anyone? Satish? Anyone else?
Sir, only pressure.
Only pressure. Yes. Good. Only pressure. Temperature? No. Okay. So yes.
Then what was maculose and slatty? They are classification of metamorphism or
They are the structures. क्या स्ट्रक्चर देखते हो उसके अंदर, किस टाइप के पैटर्न देखते हो, these are the structures. Okay. Like in sedimentary rock we see stratification, means horizontal layers one after another. A stack of horizontal layers you can see, that is called stratification. Section B तुम लोगों का थोड़ा प्रॉब्लम हो सकता है, because I didn't discuss this part yet. So similarly, what kind of structure you see here? You are seeing a slatty structure. Okay. And here you are seeing a Systole structure like this. So slatty and Systole may difference here. The difference between slatty structure and Systole structure is that the weak planes, here the planes are a weak plane, but this is not quite common in the Systole structure. So a foliated rock which is coarse grained and is largely composed of flaky and platy minerals is called schist. Flaky minerals are like mica. So the things, the white toppings you can see on this rock is actually mica. Okay. This is also very important. It's called the Nissa structure. So how they look like? It look like there is a two band, light band and dark band, and this is very visible. They will be seeing alternate light and dark band. So in rocks that have been thoroughly recrystallization under the condition of high grade metamorphism, अच्छे से time मिल गया. They got enough time, the rock is undergone for enough time of metamorphism, then this type of structures are formed. See here, white band, then dark band, then white band, then dark band. The light and dark colored band, the alternate of light and dark colored band you will see. So dark colored band basically composed of biotite and hornblende. So what is biotite? Biotite is the black mica. Light band is composed of quartz. Quartz is a quartz has a generally glassy structure, so not glassy, glassy would be a totally different term. Quartz has a shiny structures, like, okay, so quartz is very shiny, quartz and feldspar. So this is basically light band structure. It's a light colored mineral, so it will form a light band structure. Okay, and this type of metamorphic rock branded, showing the branded appearance, it's called the niche. It's called niche. So when I'll be referring niche, that will be the Nissa structures I am mentioning, and the structure is called Nissa structure, but the rock will be called as niche. Okay, so these two are very important. Next will be your granular structure. So granular structure, evergreen structure, is produced due to the predominance of equigranular minerals such as quartz, feldspar, pyroxene and calcite. The flaky minerals are absent or present only in small amount on breaking a granulous rock, producing a rough fracture surface. Okay, and it is produced due to the predominance of equidimensional minerals such as quartz, feldspar, pyroxene and calcite. So this type of structures is called the granular structures. The examples are marbles, basically limestones converted into marbles. What is a marble? Marble is limestone, which is a sedimentary rock, is metamorphosed and it become marbles. If you see limestone and marbles, the maybe chemical compositions doesn't change as the atomic level, but the nature, the property basically changes in metamorphic rock. A different type of rock emerges under high pressure and temperature from the existing rock. That was called the procedure of that was called the metamorphism. That process is called the metamorphism. Okay, so this is the granular structure, and hornfels structure are generally dark, compact and fine grained rock having granoblastic structure. So I have already discussed what is a granoblastic texture. If you found any structure that dark, compact, fine grained rock, then it will be considered as a hornfels structure. Structure means ki, what do you understand by structure? Structure means its appearance, how the thing look like, maybe by microscopy way or maybe in a naked eye. How generally they appear on the nature or in the nature. How generally they appear in the nature. How generally they appear as a metamorphic rock. What type of structure you can see, means हम लोग बोलते नहीं, एज ए सिविल इंजीनियरिंग स्टूडेंट यू जनरली टॉक टू लाइक दैट द बिल्डिंग का स्ट्रक्चर ऐसे होना चाहिए था, बिल्डिंग का स्ट्रक्चर ऐसा होना चाहिए था. सो दिस इज काइंड ऑफ द अपीयरेंस. ओके, दैट आई मीन. नाउ your work, you have to read it by your own, and I have already discussed the terms. So you have to read the properties of the metamorphic rocks, just like the igneous and sedimentary rock, and these things are very important. I might ask any question from here, from igneous, sedimentary, metamorphic rock properties. I might ask, so write down the properties of slate. So you have to write down slates are dark colored metamorphic rock. Okay, and it is basically composed of very grain mixture of micas and chlorite. How they generally formed. Okay, what is phyllite, what is phyllite, what is schist, what is limestone, what is gneiss, what is quartzite, what is marble. Okay, what is hornfels. So I will provide you a study material and the PPT. These things you have to read it. Okay, so read in details from the study material. These things are very important, very much important for you. So I might ask a question from here. So write a short note on marbles, or write the properties of marbles. Then you have to write the property of marbles. So marbles, how marbles are formed. Is it crystalline calcareous metamorphic rock? It has a granular texture. It is composite of calcite or more rarely dolomite. So marbles are basically calcium carbonate, right? Then what is the texture, what is the structure, like this point wise you have to mention in your exam. Is it clear to everyone? Is it clear to everyone? Class?
Yes.
Okay.
Yes, sir.
Okay. Now after metamorphism, what happened? Cells generally converted into greenstone or hornfels. Quartz sandstone, this is important, write this down. So quartz sandstone metamorphosed into quartzite. Sandstone metamorphosed into quartzite. Limestone metamorphosed into marble. So sandstone metamorphosed into quartzite. So the igneous counterpart, so igneous or sedimentary counterpart. So this is the existing rock, and this is the metamorphic rock. Okay. And limestone generally transformed into or metamorphosed into marble. Okay. ये भी पढ़ लेना, ठीक है ना. Now why these rock types or rocks are very important? These are importance for these are act as a building stones. Like I have already mentioned that limestone, that is your sedimentary rock, is built or is actually the Great Pyramid of Giza and the surroundings of that area, of that pyramid area, or at least the faces of the pyramids or any structure like the Sphinx. You might know the Sphinx in Egypt. So that structure is made up of limestone. St. Paul's Cathedral is a famous place, it's a famous tourist place to visit, and many other buildings are made up of limestone. Okay, so limestone, depending on the places, limestone could be different. So you know Bindhan limestone. Bindhan limestone is used for many historical places. Bindhan sandstone. So Bindhan sandstone is used as a good building stone in many historical buildings in Delhi, Rajasthan, Agra, Red Fort. Okay. Basalt generally used in road materials. So road metals you use, that is actually basalt. Granite is also used. Granite is a igneous rock, you know, plutonic igneous rock. Granite is generally used in और रेलवे के ट्रैक में जो पत्थर रहता है ना, that is actually granite. Washington Monument, Taj Mahal is made up of marble. Basalt, sometimes you will find some structure with basalt, and rubble masonry works for bridge piers, river walls and dams sometimes, or in the ancient age at least people use these things as a brick. Okay, the block of basalt is used as a brick to build bridge piers, river walls and dam. Okay, so that's it, I think. If you have any question, just let me know.